This is the track of Qt in use. So basically, I'm still telling you my experiences because this huge touchscreen measures 8 meters, and we built it from the ground up using Qt widgets, using OpenCV and C++, and then we used a Qt network for doing some network stuff. And finally, the user interface was used with the latest technology, Qt Quick, and some shader stuff. In the way to build it, we faced several problems. Many of them were Qt bugs or Qt creator bugs. So we're really pushing the frontiers of Qt with this project in Mexico. So this is why I'm going to talk. What I already told you. Then why we build it. And then I'm going to tell you what we started doing, because we started doing surfaces for the entertainment market. We started with bars and pubs, and then we ended delivering finer technology, and then we started creating these touch screens. And of course, I will tell you what's inside. That's maybe the most interesting part for you about the internals. And this is not really a technical talk. I will tell you an overview of it, but I have code samples here if you want at the end of the talk. So, what this is me. I'm a founder and lead developer of Edis Interactive. Maybe the Qt trolls will almost hate me because I'm always pushing new bugs at the bug tracker, especially in Qt Creator and Qt Quick. Well, at our company, we create huge interactive surfaces for education. In the past, we did it for bars and pubs. So this is what we started doing. This in the time when we did this, there was only QGL widget and there was Qt4. So it was quite difficult to create these things. These things are animated. These are for fun. Basically, when you turn the bar into a touch screen. There's a German company that already did this with a different technology, and they eventually, I think they sold to a London company. It's called iBar, and they commercialized this technology. And eventually they moved to Unity 3D. So we stuck with Qt. We tried to build a framework around it. It was a lot of custom animation and a lot of OpenGL. It was quite difficult in that time. But then our core technology was multi-target tracking. So multi-target tracking in this case is detecting pieces of stuff all around the table. And then we refined the technology and then began doing this. This is the main core of this talk. Well, all about 1 year later, when we refined the technology, we started doing this, and we rewrote the tracker with C++ in Qt5. It was from Qt4. We rewrote it in Qt5. And we added some other new technologies that we've been finding in the way in Qt Quick. Specifically, we were injecting touch points using the 2U tracker. But now we're using QPA plugins and Qt Quick. So for this, we're delivering a lot of custom effects with effectors and a lot of Qt Quick. So how was it done? This was done in Mexico. It was financed by the Mexican Council of Science and Technology, and we created a consortium of a couple of universities. It was 2 universities and the company who created this touchscreen. The central purpose of the touchscreen is for education, and we used this as additional funds for the company. So we were a startup by then, and we were kickstarted basically with this project. So this is the building of the touchscreen. That's just half of it. What technology we used. There's 2 glass panels. We use a technique named laser light plane. We use different cameras, infrared cameras, protecting the touch points. Several projectors, and right now we use accelerated Cinerama over Linux with several NVIDIA cards. So how was it done? Specifically, the software part is interesting for you. So it was by then Qt 4.8, I think .7 or .6 even. And then we upgraded to Qt 5. By then, Qt Multitouch was in the very early stages. So I remember seeing one of our videos of the early prototypes of the touchscreen being used by Brad Hughes by then in some demo for Nokia in those days. And then it was all the infrastructure for Multitouch, and I followed closely, and we were basically giving ideas and collaborating on the creation of the Multitouch framework for Qt 5. So we created a tracker, because I don't know if you're in this talk, maybe you know CCB, a Multitouch tracker, open source, that uses open frameworks. And by then, CCB wasn't really that reliable. Even by now, its reliability is not quite strong, but it has come a long way, and it works quite nicely right now. Additionally, there is a Multitouch protocol, very known in the touch community and the interactive community. It's known as Tuyo, and Tuyo delivers Multitouch data and also additional data for tangible objects and other objects using the network. And by then CCB was single camera only, and by now I think there are some plugins or some unstable software additions for CCB that allow it to be multi-camera, but not in the way that we need. You will see some coordinate mapping, some weird things that we do that need this. And finally, we were almost forced to use a QML-like viewer, a QML scene-like. Because we found very interesting things that, for example, I give courses for college people. The last talk here was about not enough people learning Qt, not enough people coming from universities. And as part of my job, I give courses on college. It's just one course every week, but I gather lots of people interested in Qt, and these people are like, take it. It works for the first time, or they hate it because they are students coming from the first year in college. So they like to create awesome things with 2 clicks. We try to make life easier to them, and we create a QML scene-like viewer. But let's dig a bit more into this. This is our tracker. It was originally written in Qt widgets with Qt 4.6 with OpenCV. This is the window, the main window. And eventually it was ported to Qt 5. It has some interesting bits on it because I don't know if you know machine vision. There's a very known framework named OpenCV, and they have this IPL image, and Qt uses QImage. So there are some implementation about how to translate both without copying memory. And there's some image and IPL image and QImage translators, which allows us to be very fast. Also, another interesting bit is we split core and user interface with this. The core can run even headless. Now we're trying to embed it. We're mostly working on taking it to the Raspberry Pi for doing the tracking on the GPU, because most of image processing can be done with GL, and the final step, the tracker, can be done in software in the CPU, not in GL. But most of the hard work that we use here can be done in the GPU, even in the Raspberry Pi. Well, this is what I already told you. Second part of this is the tracker, the muxer. There's a multiplexer. We use several trackers, several cameras to detect touch, and we mix them. There was 2 choices, or either we implemented multi-camera support in the tracker, or either we put a proxy in the middle. So we opted to put a proxy in the middle, and it was the Triangle tracker multiplexer. It takes any amount of 2U inputs, that it's basically data coming from the network, and like this one, and it delivers only one flux of data. It can do coordinate remapping, and it can easily be configured with this JSON style configuration using the JSON support in Qt. We have tested this Moxer. It uses Qt network, and it basically can deliver one flux for even to 10 inputs. So it goes quite fast. So you can create pretty huge interfaces. This is the way it works. We have several cameras, several projectors, and basically the Tarango mixes them all and gives one single output. There was an additional step because in Qt4 we used an injection mechanism of touch points into the system of Qt, but it was not nice. It was a hack. It was put there, and there was mostly a private symbol in the libraries. You had to do some weird stuff to use it. But now they invented. I think this was named the Lighthouse project, and then now we use the QPA plugin to basically turn this input that's really coming from the network into a real touch device. And now after we do this, basically everything works because it is now a normal touchscreen. So it can be used as any other touchscreen. So everything in Qt Quick and everything in the touch framework works nicely. Well, this is how it works. It's just the console application that can be launched headless. Even now, the tracker the Tarango Moxer can run in the Raspberry Pi. So a Raspberry Pi can be used as an invisible proxy for this. I think there's another talk about invisible hardware. I don't know if it's the same topic, but it's closely related because you have several trackers in the background, and then you have one Raspberry Pi translating and giving output to only one tracker. The other part only sees it as a single machine, a single tracker, a single touchscreen. And using the QPA plugin, you see it as a real touchscreen. So the last part we did was the user interface thing. And even when it seemed like the easy part, it was the hardest part. We went into OpenCV, machine vision, network stuff, dissecting network stacks, and say, well, the user interface is the most easy part of this. But it resulted not, because we had two targets. The target B is us, the developers, senior developer, junior developers. They have wizard level technical knowledge. They have no problems here. And the real problem is target user A, which is the most important, or was the most important to the universities. They are in a career named Interaction and Animation Design. So they are basically designers that know a bit of programming. Like the marketing from DG is marketing mostly Qt Creator and Qt Quick for designers who do a bit of programming work, and there is a backend in C++ who is do the heavy job. But the people coming to Qt Creator, the people who I teach, they're mostly designers. They know Adobe Suite. They like those things. They like even Flash. It's quite difficult to teach them C++. So I don't. So as I tell you, they like it to work it at the first shot, or really they hate it. They say, no, then I will go maybe to the Adobe Flash or something else. It's quite interesting, their behavior, because I was used to work with people with more patience. Well, they basically like this. Oh, my Multitouch app, magically it works in the big screen. Then I can take a nice picture and say I'm the next Tony Stark. So, easy. Let's teach them how to deploy apps using Qt Creator. Yeah, okay, target user A, you're a college student. How to deploy apps. Just open the tool, and you go to build and run, and then you select a compiler, and then you create a Linux generic device. Don't forget to put the IP address, the password, and to test it. Step 3. Okay, create a kit. Okay, if you have several, maybe you need to duplicate settings because you might not be skillful enough to know what to put that you duplicate. Okay, then select your generic device there, and then select your device and select, and don't forget to be in the LAN. And what we received as response from them says, you promised to be easy. When they come to my course, I say, this is easy deployment, easy creation of multi-touch applications. And they say, well, this doesn't seem that easy. So we can really use the normal workflow with them. So we had to create a new mechanism. And what we found is that they found really easy to use the Wizard new project, create new user interface, and without compiling anything, just going and hitting play. So that's why we tried to reproduce. We allow them to create a user interface. We allow them to do what they already know, and we set up a Samba shared folder. So they can create a Qt UI. They have some. I teach them how to create them. That's the goal of my courses. And then they magically just move the folder to this shared folder in the multi-touch screen, and it works. For this to work, we need to set up, well, the Samba shared folder is the easy part, but we needed to create some infrastructure behind. This is what we created. They create the user interface, but then we created this QMLC-inspired viewer. It is just a Qt application that's just monitoring a local folder. And whenever it sees something new, it just loads it, and it works magically for them. So they just upload their folder, and they're happy with them. And now we have lots of new small programs being developed by the students. And we even created a new design your own program on the touchscreen using Q images. So they just link some Q images, and they basically prototype a user interface on the Q screen very easily. Just they link images, and then they hit next and or hit some hot points, and it seems to work. It seems to be a real application. But for first semester students, this is quite useful. And for academy, it's also very useful because they can prototype these interfaces on big screens, and they can produce research papers very easily. So the problem was solved with this. But it was not charming. And I will show you a picture because it was really not really professional. We needed to make it cute. It was a bit ugly. This is what we ended with. But we had some problems. Maybe you don't see it in the projector, but there's some, these parts and the other part, it's ugly. And it is ugly because we use multiple projectors. And you have to be very careful when aligning your projectors when you don't have the software, for example, some expensive software to blend them. Well, it's more visible for spectators, so it looks very unprofessional. So I'm calling about these overlaps that are not very nice, and they look really ugly. So how to make it cute? We need projector edge blending. But this is not an easy problem. This is a whole different area to tackle. I grabbed this image from Paul Burke, and he explains about projector blending with cheap projectors. But basically what you do is to slice your image and to overlap your projectors. That's easy to say. In addition, you have to darken the edges, apply some filters, So when you reblend, you don't get these rough edges. So the general idea is this. You overlap your projector instead of carefully aligning them, and you split your segments, you darken edges. And the fourth step is another challenge, because you need to rewarp your mouse or touch coordinates on this, because if you don't, you will end up, you basically end with touch points on places you don't need them. So it's not funny. But if we do the general idea, we really have fun. Well, these techniques are sold by several companies, and I don't know here, but in Mexico, the software is very expensive, or the hardware is also very expensive to do. So, but, well, the first part, to overlap projectors instead of aligning them. That's easy. Just move the projector. Next. How can we do this using Qt? Basically, how can we do this using the easiest part of Qt, that is Qt Quick? Well, the general idea was talking about edge darkening and splitting a texture. And we already have a texture in Qt Quick. I was, for a couple of days, nagging people at the IRC channel, asking for some stuff, and reporting my findings, because I found some bugs. People told me something would happen, and it happens. What I found were different. But anyway, I can put the whole scene as a shader effect source. So I just nest my scene in another in a subtree, and I just render the needed slice. And while I am there, I just darken the edges, and I can. You can darken the edges, or you can put a smart control to know how much to dark, because you cannot overlap perfectly your projectors, and also they are not perfect, so their brightness is different, and even color. Another thing is color matching. But well, we didn't tackle color matching, as we got quite decent projectors that didn't need this. So this is the same slide. You just render using shader effects several times, and use the same shader effect source. You can put some handles there. What I was talking about something that scanned a folder. Is basically this. That's the menu, and the other thing is the blending. There are, especially this application that you see here is where we found a couple of Qt bugs. For example, WebKit refused to render. That was the hardest one. And well, it's now solved. Okay, then we did this. We got the edge darkening, and we got the splitting. We got it working. We found the bugs. We worked around the bugs, because by then they were not fixed yet. And then you still need to align your projectors very carefully. So you need something called homography warping. This kind of thing. If you, the first idea you get is that once you have this shader and darkening, you can warp the quad. But if you warp the quad in the wrong way, you get basically things like that. The image does not translate correctly. The coordinates get wrong, because you don't have a correct perspective. Basically, what happens when you move a projector is that you move a perspective, and when you warp like that, basically that kind of things is what happens. The coordinates get incorrect. So you need what's called homography warping. This is basically some math. You calculate you solve a system, and you calculate what was the inverse mapping of the move of the projector that you did. The formula is very easily found, and The thing is how to correctly implement it in Qt and in C++ and then translate it to Qt Quick. But once you have it, you start here and you end here. As you can see, it is wrong. The image is wrong. You can see those artifacts, but it's wrong because this is a correct flat screen. But when you put these three parts into our three projectors that are basically awfully aligned, the image realigns correctly, and you end with very nice images of the screen. So, and in the step 5, we put the projectors wherever we want. As long as we have blue screens, we put any technician and say, hey, fill this blue screen with the projectors however you want. And then another people goes and aligns them. So we started with this, with the ugly artifacts. And we ended with something more like this, where you still see some artifacts, but not quite as intense as this. This is really ugly, this and that one. And you end with these ones. Especially here, it's almost not noticeable unless I tell you there is some blending. And this screen shows only brightness because we didn't put the fourth projector yet. But we need just a fourth projector in order to this to be perfectly nice. Yes, really, it's very difficult to see any imperfections. There's one there, but it's only brightness. Yeah, we went in the 4 or 5 steps, but there's only one step that we missed here. I didn't explain. That was this: how to rewarp. How to rewarp the coordinates. It's a very important step because you can have a very nice screen, very nice blending, application running, but you cannot interact with them. And it happened that we already had the solution in place. The triangle multiplexer remaps coordinates. And we can use the triangle to remap only pieces of the coordinates. We basically remaps segments from 0, 0 to 1, 1 at the beginning, multiple 0, 0 to 1, 1 boxes, to one single box from 0, 0 to 1, 1, slicing in 3 parts. But now, we still take from 0, 0 to 1 3 or 4 parts. But instead of remapping it to 0 to 1, we remap it to the correct slice that we have. And after 1 or 2 experiments, we found the correct mapping, and this was already put in place. So we didn't need to remap coordinates at the Qt level or using QPA. We simply used didn't map the whole screen to a whole screen, but to a slice, and it worked. Also, it worked because when we created the nested scene, the scene was using the whole screen. So what the shader source here. The shader source just renders in a very small slice. But the real widget, the real Qt Quick element, basically the one that contains everything is running, but it's running in the whole screen. All the screen that you don't see at the bottom, all the screen that you don't see in the top. So just by remapping the coordinates, it worked. Oh, yeah, it worked, but we got remapping of network traffic, not remapping of real touch point coordinates. For this, we just implemented the Qt platform abstraction plugin, and then we injected all the touch points into Qt. After that, everything went smoothly. Well, with this, with a platform abstraction plugin that listens for a 2U input at launch, sets up a touch device, and maps all the 2U cursors to multi-touch points, pinch area, multi-point area, and even mouse areas all work as expected. So this is in our resume. We created for working with the screen, we create a Qt Quick UI with Qt Creator. We copy and we use it, and it magically appears on the menu. So this is why I came here to talk. It's my experience building it. I have some code samples if you like, or if you have any questions, I'm open to them.
Curious to know how many machines you're running. You're running one machine for the computer vision, and one for the projection?
Yeah, in the beginning, we had a big project, and we had plenty of computers. So we didn't save anyone. And there is one machine for each camera, and one machine for the user interface, but it's not really needed. Right now, we wouldn't like to take them away, because the multi-touch screen and the servers are becoming almost an attraction at the university. So they go and see the whole rack of computers. But the truth is that we would need only one for detection and only one for the user interface, and maybe the same machine can do both. Another thing is that we are using now, trying to move everything to the Raspberry Pi.
You have a triple head graphics card on your...
I got two NVIDIA cards, dual head. It's because we're waiting for at the end we need to put the fourth projector. So we use 3 heads out of 4 we have.
So you're tracking the touch points with the cameras. Is the back camera and you're filming through the glass panel, or how do you make the tracking with the camera if I'm standing before it? So that how do we interface with that I stand before and touch something the camera can't see before because I'm standing there?
There's a technique called light laser playing, and basically the camera is near to the projector, almost at the same level, and you don't occlude the camera, because there's the laser goes maybe 1 millimeter over the glass, and when you touch the glass, you cross the laser, and your finger shines in a wavelength that camera sees, and with a multi object tracker, you can get a touch point tracker, or even you can track anything. We have a project right now for motion capture. That's basically the same. We have a limit. Well, in theory, we don't have a limit, but we have a limit in the tracker. The tracker can handle nicely about 96 touch points, and we have 4 for it. So you could say that it could be 400. But truth is, we found some interesting things in the screen. There are some places in the screen that the people tend to not use. I think it's too big, it's almost like this wall. They tend to stick to one place, and they like to walk 2 or 3, maybe 4 steps, but not to the other side. So this has to do with user interface, research, and Academy can tell more about it. But it's interesting what we found with the multi-touch screen this big.
So you're using line generator on each of your lasers?
Yeah.
I'm curious how many lasers you
I don't. It was planned to be about 40 lasers. At the end, we're using about 12.
And they're all perpendicular to the glass?
I mean, no, parallel. Yeah, because you have the glass and you have a line generator, and it goes closely.
But you don't have any in the corners? It's all...
No.
How many people usually are using this thing at the same time?
It's well, the idea is that several people, and we thought that at least 2 or 3 can use it because it's comfortable for even 4 or 5 people to use it. But in reality, it happens. What happens in a whiteboard, in a blackboard, people tend to sit and watch, and then they exchange roles. Sometimes, at most, 2 people are using it at the same time. But I don't know. This has to do with metaphors. With people are used to interact with screens. In classrooms, you usually use a blackboard. Many people sitting and 1 people writing, and then you exchange. And the screen is using the same way. It's being used the same way. We didn't encourage this. We just that is just our findings.
So, more questions?
Yeah. Do you have any examples of applications that are being used with this?
Yeah, I have some videos here. I don't know if I have time. No, I don't have them any videos, but I can share it to you and even in the Twitter account. I already tweeted one video. Maybe you can watch it. And we have a new project in Mexico. They're using it for tracking police, ambulances, and firemen, and also cameras in a northern state. Security stuff in Mexico. So there's a project for that, for basically orchestrating security in cities, in whole cities in Mexico. For this, there are already walls of LCDs, but they are not interactive. You can interact directly. You need to use keyboards or different computers to bring content to the video walls, basically. But with this, you can be a commander of the security in one screen, and you can get much more information from it just directly touching it. For example, we have another project with INEGI in Mexico. It's an entity that gathers information or statistical information from population, geography, and many data in land in Mexico, how the soil is used. And there's an ongoing project at the university at Ibero Puebla for bringing all that information into the multi-touch screen. So to analyze where to put, they're putting oil pipes in the ground, and they're moving people. There's a big reordering of the population, or the areas where people live, and it is an easy way to manage it, to see it, because, for example, for INEGI, maps are already big. They use paper maps, very big, and they don't have all the information that a screen this size can give.
So,
no, that for this kind of systems, the resolution depends basically on the type of the sensor on the camera. So if you get a very good sensor, you get quite good resolution. Our sensor is not that impressive. It's 640 by 480, and even with that, you can get quite decent resolution. So what becomes a problem here is your own hand occlusion. What you occlude with your own hand. Not the touch points, really.
So, thank you for your talk. It was quite exciting. Now I want to touch a thing in my living room.
we're doing it also for museums, and maybe sooner or later you will get one.
But yes, thank you. And,